Hi guys, this is Dr. Diaz again, and today we're going to solve exponential equations and logarithmic functions. So first let's start with this problem 12 from the review, and then I will solve like probably 4 or 5 of these problems. It's the same that in the PowerPoint from the review to help you a little bit to understand these. So first, this one, 4x, and we can rewrite this one like this: 4 power to the 3x minus 1 is equal to 16. The way to solve this problem is by using this rule. When the bases are the same, this is the same number, you can equate the exponents. That means in this case, this implies that m is equal to n if we're looking here to solve for m. So in this case, we would like to do the same thing. Unfortunately, 16 is not the same as 4, but we know that 16 is equal to 4 times 4, which is equal to 4 squared. And this is what we want. We want this 4 3x minus 1 be equal to 4 squared. And now that the bases are the same, we can equate the exponents. So this gave us that 3x minus 1 is equal to 2. We send 1 to the other side, we will have that 3x is equal to 2 plus 1. 3x is equal to 3. We divide both sides by 3, and we get that our answer is x is equal to 1. Yay! Here is B. Okay, we're going to do another problem. Here we have problem 13. This one says log of base of 25 of x is equal to 1/2, right? So how do we solve this problem? We have to solve here for x. Let's rewrite the problem then here. Log base of 25 of x is equal to 1/2. Here you have to use one of those rules of logarithmics, and there's a bunch of rules of logarithmics. There's actually a PDF file formula with all these rules that I would suggest you download and have it at hand when you're solving these problems, because I don't want you to memorize all the rules, but you need to know how to apply them. And there's one rule that it says b log of b of x is equal to x, because b and log of b of x is actually one is the inverse function of the other. And we can do something else. We can put this as a generalization. We can put it like this: b log of b of f of x is going to be f of x, right? So in this case, we need to look at the base. The base here is 25, right? So how we solve this one? You see, it's like putting here 25 log of 25 of x is equal to x. Or in this case, it will be 25 log of 25x is equal to 25 to the 1/2. And here's the thing: if you put a 25 here, you have to put a 25 here, right, in order to get the equation balance. And now we know this one here. If you apply this rule that we have here, b log of b of x is equal to x, then 25 log of 25 of x is going to be equal to x. And x is equal to 25 to the 1/2, which is the same as the square root of 25, which is 5. So x is equal to 5. Now you have to remember here the exponents rule. And there's one example here. When you have something like x to the 1/2, this is actually what? Square root of x. You have x to the 1/3, this is the cube root of x, right? Or x to the n divided by m, this is what? The n root of x to the n, right? The denominator here is always the root. That's it. Okay, we're going to do another problem in a second. Okay, now this one, you also need to apply one of those logarithmic rules that we work in a little bit, or at least I mentioned a moment ago. And Look, we're going to do exactly similar, something similar to what we did in the previous problem. We're going to use this rule. B log of b of x is equal to x, right? Yep. So let's apply it again. We know the base here. Let's write here the problem. The problem says log base 4 of x minus 3 is equal to -1, right? The base is 4. So the base being 4, we're going to do 4 log of 4 of x minus 3 is equal to 4 power to the -1. Okay, 4 log of 4 of x minus 3 is going to be x minus 3 is equal to 4 to the -1. Now, what is 4 to the -1? Then you have to review exponents here. If you have something like x to the -1 minus 1, as you said, this is the same as 1 over x. So in this case, 4 to the -1 is the same as 1 over 4, 1/4. Great. So now we have here x minus 3 is equal to 1/4. We had to send 3 to the other side. So we will get something like this. X is equal to 3 plus 1/4, right? Because when -3 cross the equal sign, change the sign. In order to add these two, you know that these 3, let's put it here, you have to multiply top and bottom by 4, because that way you will have the same denominator, and you can add this number plus 1/4, right? If you cancel 4 and 4, you will get 3. That's why we did that. So doing this, we will have what? 3 times 4 is 12 fourths plus 1/4. Now that they have common denominator, let's get right in here. This is going to be equal to what? 12 plus 1 divided by 4. The answer is 13/4, which actually is D. Okay? So we will do. I'm going to do another 2 problems about logarithmics, and I will see you in a second. This will be the second part of this problem. Bye.